Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about Fixart, one more application of divide and conquer algorithm design strategy. So first of all, what is a problem statement? You are given an array of n elements. The Quicksort problem is sorting the elements of array by splitting the array into two subarrays and sort each subarray recursively. Now, Quicksort works by partitioning the given array A P2R into two non-empty subarrays A P2Q and A Q plus 1 to R. So here you are given a global array A P2R. That A P2R, P is the low index and R is the high index. A P2R is divided into two subarrays. One is A P2Q and other one is A Q plus 1 to R. Now, such that every element which is present in A P2Q is less than or equal to every element which is present in A Q plus 1 to R. So here, directly dividing of array cannot be done as in merge sort. Just here, in case of merge sort, we are finding the mid value. At the mid, we are going to divide the array into two subarrays. But here, we are not doing that one. First, we are going to do the rearrangement of elements. So here we are doing partitioning. How the partitioning is done? By the rearrangement of elements. How we are going to do the rearrangement of elements? We are going to select one element as the pivot element. And here we are going to arrange the pivot element in such a way that all the elements which are present before pivot element are less than it, and all the elements which are present after pivot are greater than it. But they may not be in sorting order. They are all greater, but they are not in sorting order. All the elements before it are lesser, but they are not in the sorting order. Now, at the pivot, we are going to divide the array into two subarrays. So here my Q is the pivot element. If my Qth position is the pivot element, A P2Q is one subarray, A Q plus 1 to R is another subarray. Like that, we are going to divide the array and we are going to sort the array in case of Quicksort. Now here, I'm going to play one small video which explains the procedure of Quicksort. Listen that video and try to understand. So hope that you all understood how Quicksort is working. Now you can see one more example here clearly. You are given a list of 9 elements. So first here we selected the first element as the pivot element. So from the left side, we are finding the element which is greater than pivot. And from the left side, we are finding an element which is less than the pivot. Here 40 is the pivot from left side. Immediately the next element 90, which is greater than pivot. From this side, here we are going to find the element which is So some small mistake is there. Let us assume that, yeah, correct only. So here we are finding the element which is less than pivot. So here you can observe that 50 is greater than pivot. Pivot is 40 and 45. 45 is greater than pivot and 20 is less than pivot. Now from left side, the greater than pivot element is 90. From right side, lesser than pivot element is 20. These two are to be swapped each other. So 90 comes here, 20 comes here. The same procedure follows. Next, from right side, next element 60, which is greater than pivot. Before element to this 90, 10, which is less than pivot. These two are again swapped. So 60 comes here, 10 comes here. Now again, the next element 5. Here this is not greater than pivot. Now before 60, 13, this is also not greater than pivot. Right. Now here we are going to arrange the pivot element with this element. Since I am not finding the greater and the lesser elements, so that's why. So the greater element becomes here 60 only. 60 already rearranged. So that's why here we are moving this element. We are replacing this element with the pivot element. So here 13 comes here, 40 comes here. Now pivot is rearranged. Pivot is rearranged means that is present in correct position. The elements which are present before pivot are less than it. The elements which are present after pivot are greater than it. So what we are doing is, first we are selecting randomly one element as the pivot element. We are finding the greater element from this side and we are finding the lesser element from this side. These two are to be swapped each other. The same procedure continues. Here greater element, here lesser element. Two are swapped. Here this is not greater, this is not greater. And this is the greater element. And coming to lesser, this is the lesser element. But here this 60 is already rearranged from here, right? So that's why this 13 is replaced with 40, is swapped with 40. So that's why 40 comes here, 13 comes here. It is divided into two halves. This is one half and this is other half. But the elements are not in sorted order, right? Now this array is again sorted in the same procedure. 13 is taken as the pivot. This is a greater element and this is the lesser element. These two are swapped. And here, when I am moving to this is the greater element and this is the lesser element. But 20 is already swapped. So that's why 10 is replaced with 13. So this becomes left subarray and this becomes right subarray. Since this contains only one single element, this is already sorted. Here, the same procedure is followed. 10, 5. Both are swapped each other. I'll get a sorted subarray here. The same procedure is continued here. Same procedure continued and we will sort the array and they are to be combined to get the sorted array. Right. Now here, this gives the algorithm for quick sort. Here we are going to sort the subarray A, P to Q in the given global array. Now, if P is less than Q, select A of M as the pivot element. M is equal to partition of APQ. How we are partitioning? M represents the position of pivot element after rearrangement, right? That is, at M, we are dividing the array. So we are calling quicksort for the subarray. First subarray, P to M minus 1. We are calling the quicksort for the second subarray, that is M plus 1 to Q, right? Now, how partitioning is done? This partitioning algorithm can be represented here. What the procedure just we explained now. So we are selecting we are selecting partitioning algorithm. How we are interchanging, how we are selecting all those things that are represented here, right? Now, that coming to the time complexity of quicksort, the time complexity can be represented with the recurrence relation. T of n is equal to a when n is equal to 1, 2 into T of n by 2 plus n when n is greater than 1. So where a and c are constants. So by solving this recurrence relation, any of the methods we can use, we will get the time complexity as big of n log n. Right. So I hope that you all understood how to solve quicksort problem. How the elements are sorted using quicksort. So I hope that you all understood both merge sort as well as quicksort and the difference of merge sort and quicksort. Thank you for listening.